So we will understand the scope of for each and parallel for each today. How does the mule event structure change as it moves from one component to the other with these two scopes, especially inside each scope? How does the payload and the variable change? What is accessible after the outside of the scope and inside of the scope, and so on? Because understanding the scope of the mule event structure is very important to know which payload is available when, or which variable is available when. Okay, so that's the first thing, understanding the scope of for each and parallel for each. But I have also another topic, the last 10 minutes or so, I will spend the time to show you how I am using Google Keep. So last time, since after Anwar showed us organizing our notes using OneNote, I was comparing Google Keep and OneNote, and I switched to Google Keep for a couple of reasons. So some of you may like it. So for that reason, I will show you how I am using Google Keep, how Google Keep compares with OneNote, and the pluses and minuses of each one of them, especially Google Keep as compared to OneNote at a high level at a high level, because I don't know OneNote very well. So let me share my screen here. So as usual, I have the project and also hands-on quiz for today in the course GitHub repo. So you can fork it from there, clone it again as usual, and use it for your reference. But first, before you just download that, it is good if you build it yourself after understanding the concept. Okay. So I have this table together. Let's try to understand each one of them. And also I have the documentation for each one of them I have added here. That's why you see each one of them is highlighted and underlined. Okay. So let's start with the first row. The first row, what does it say? For each processes individual elements sequentially. So if you have a collection, for example, an array, each one of them, they split the collection into elements, and for each processes individual elements sequentially. That means it has to complete the first one before moving to the second one, and it has to complete the second one before moving to the third one. That is what sequential means, one after the other or in sequence. Whereas for parallel, for each processes individual elements in parallel or concurrently, and this behavior of each one of them makes the mule event structure different, or it makes them to behave differently. So if you can think in terms of people, for example, if you are a parent and if you have let's say you have 4 kids, in for each, what you are doing is you give some kind of job to one child, and you wait until that child completes their job. Then after that child comes back, then you give another job to another child, and so on. Whereas in parallel for each, you are giving them jobs at the same time, and whoever is faster may come back. You don't know who will come faster. Whoever finishes the job first will come quicker. So parallel for each is in parallel. You are sending them the same time in the beginning, whereas for each is sequential, one after the other. That's what the first row is telling us. Let's try to understand the second row. What is the second row saying? The second row, it is very important. By the way, from the content that we are covering today and tomorrow, you can expect fairly 2 to 4 questions in the certification exams, because these are very important concepts. So the second row, what is it saying? After the for each, after it exits the for each, then it returns the original payload. It doesn't return payload from the for each scope. It returns the payload that was there before getting in to for each. That's what it is telling us. It returns the original payload. So even if you do any modifications payload inside the for each scope, after for each is complete, it doesn't return the modifications, any changes made to the payload inside the scope. Rather, it returns the input payload. So whatever we want to do using the for each, we have to complete it inside the for each, is what this means. Like, for example, if we are inserting the data to a database, just inside the for each, we drag and drop the insert operation and then insert it to the database. So this is in terms of, for example, in terms of the 4 kids a parent has. At the end, in this case, actually, it doesn't make sense. But what the dad is left with is the original kind of the original task. Or if he was giving them some money, we can say in this case, at the end, the for each at the end of, I think this analogy doesn't make sense for the second row. Let's just remember it returns the original payload, and we will understand it better, especially when we run when we debug our application and run it one by one. If we see for parallel for each, on the other hand, see the second row for parallel for each, it does not return the original payload. So what does it return? It returns the output message from each iteration. So you have elements and they were being processed in parallel. Then parallel for each, it collects the result from each route and gives back the result. So it is not returning the original payload. Rather, it gives us the output from parallel for each. And also the order matters. So when parallel for each returns the results, it gives us in the same order they were in before the split. So it makes it in the same order. Even if it is parallel, we say it in parallel processing, there is no order. It doesn't matter in parallel processing. However, at the end of the parallel for each, it makes sure the processed data is in the same order that it was in before the split. The last row, before we go to our application, the last row, what it says is for each, new variables or modifications to existing variables that take place when processing one element are visible during processing of another element. What this means is, since it has to complete the first one before moving to the second one, when it is processing the second data, the second element, then it knows modification is made to the variable during the first iteration. And in the third iteration also, it knows what happened to the variable in the second iteration, and so on. And the variables created in the scope are accessible outside of the scope. So for each, in summary, for each, what you have to remember is payload. Any modifications made to the payload inside for each is not accessible outside of the for each. However, variables created inside the for each or modifications made inside the for each are accessible outside of the for each. On the other hand, if you see for parallel for each, the third row, on the bottom right, what we see is, since it is in parallel, it doesn't know, each one of them don't know what is happening with the rest, with the other operations. So new variables or modifications of already existing variables when processing one element are not visible while processing another element, because it is in parallel. So each one of them are independently processing, taking care of their job. So they don't have visibility to what kind of operation is being done to the other elements. And for that reason, variables created inside the scope are not accessible outside of the scope. So for parallel for each, the payload is the payload output from each processing, whereas the variable, it doesn't return variable from the parallel for each. Rather, it returns the variable before the for each, before the parallel for each. So I have also the next slide. I think before I continue to the next slide, just for talk about the theory, let me show you what I'm talking about, and that will help you to understand it better. And actually, the other thing is also, so as I showed on the slides, I have a quiz, hands-on quiz, and also the step-by-step project. But for explaining the concept is the quiz. I found the quiz very easier before we move to the project on the slides. I will just show you the quiz. We will run it in debug mode and understand what really is happening. So see this one, for example, this flow that I'm showing. The question is, what gets printed? Try to understand, focus on what gets printed in each logger. So in each step, how is the mule event structure changing? And we have a payload and a variable before the for each, and we are doing something to the in the for each scope. How is the variable changing? How is the payload changing? And which variable and which payload do we have access to outside of the for each scope is what we are trying to understand with for each here and with parallel for each here. So we will compare them, understand this, run this in debug mode, one by one, step by step, and then I guess the project, you can just run it yourself also and understand it, compare it. If we get time, we'll do it today together. Otherwise, it will be the same concept. So see this one, the first one, we have a listener, the path is just for each. And we have payload here. So the payload is just dummy data. The project is real data. We are inserting data to a database, but let's start with this simpler one. So in the payload, I have these 4 data pointers from 100, 200, 300, 400. This is set payload. Whereas here I have set variable, and the variable name is max payload, and its value is maximum of payload. So basically here, the payload maximum of this is just 400. So the value of this variable will be 400 here. In this logger, I am just printing the payload and the variable. So as you can see here, we are combining string and the expression together. If you want the expression, we say we have been using just by clicking fx here to make it in expression mode. But this one is more flexible. Like if you want string and expression, output of any expression, to combine them together, you can just put the string and then hash sign within square bracket, you put your expression. So this one, I want it to tell me what the payload is and also what the variable is. Now, this is for each. What are we doing in the for each? In for each, we are taking a batch size of 1. That means each element one by one. So the first input will be 100. After that is processed. The second input will be 200. After that is processed. The third input will be 300, and so on, one by one, sequentially. So what are we doing? If you see in the payload here, I am making 10% discount. So just multiplying it by 0.9. So this is 10% discount. Now, what my variable, one thing, the variable name is the same because I want to see if the variable, my original variable, gets modified. That is why I'm giving it the same variable name. And its value, let me copy the value to here and show you. So its value is this. So its value is vars dot max payload plus 10. So basically what I'm doing is to the previous variable, I am adding 10. So previous variable plus 10. My original variable, when it starts processing the first element, which is 100, my variable at that time is this variable, the input variable, which is maximum of this payload out of the 4 elements, which is 400. That 400 will be an input for the first iteration. So it will be 400 plus 10. So it will print the payload and the variable here. So let me run this in debug mode and I'll show you. Is this running? Okay. So, okay, I have added breakpoints. So as we have been doing to track how as it changes from one component to the other, to understand the Mule event structure. We add breakpointers wherever we want, where we think it is good to stop it before moving forward. So I just want it to stop before processing this logger, and this logger. So the first thing is, when it gets here, I will have this payload and this variable. Here it will print the payload and the variable. Then here it will come in the first cycle, it will stop in this logger, and I will see how the payload and the variable have changed. So run this in debug mode. Okay. So there is some error here. Okay. This one I can call it R10. Not sure if that's error. Okay. So we are focusing with the first flow for now. And this is a path, so I can go to Postman and send a request for each. And request, oh, okay. Is there an error? Okay, deploy it. I'm clearing it first. Send. Okay. Now it is deployed. So try to pay attention here, please. And if you have any questions, I will take questions you have at the end. Okay. So let's see to understand what we have. So at this stage, we have a variable, one variable. Its name is max payload and its value is 400. That makes sense. It is from this calculation, which is max of payload, and the payload we have is 100, 200, 300, 400. As you can see here, our payload has 4 elements, and these are the payload values. That's clear? Okay, now when I click next processor button here in the console, it is going to tell me the payload and the variable. So click next. If you come here in the console, what do I have? The payload is 100, 200, 300, 400, and the variable is 400. Okay, now we are in the for each. Let me click next processor and show you. So it is going to process it one by one for each element. In this case, we just have only 4 elements. Okay, go. Okay, the set payload, which is 10% discount, when it processes the first iteration, the payload that you see here, one thing, see the payload. The payload value here is now 100, the first one. It analyzes the first one first, the first element. It can be anything, or it can be an object or anything from the collection. So I have 100. It is going to multiply it by 0.9 because we are applying a 10% discount. So my payload will change to 90. 100 times 0.9 to 90. And my variable will be the original variable plus 10, which is here the variable was 400. Now it will be 410. Let me click next and show you. My payload has changed to 90, as you can see here. And my variable, I want to show you my variable here. There are other variables that we didn't create related to for each, including the counter. I think this is just, it counts the number of elements that it has processed, the number of iterations, and there is also a root message. But our variable is this one, max payload. Its value is 400. Now click next. I added this logger just to print a line break for us, just a horizontal dotted line, nothing important. Okay, now click next. So it has printed that line break. Okay, what has it printed? You see the payload for the first iteration. What is the payload? The payload is 90, which is 100 times 0.9, and the variable is 410. 400 plus 10. Okay, now the second iteration, as you can see, for the second iteration, the payload, you see it here, it shows 200. Our variable is 410. These are the input for the second iteration. So our second iteration, the payload will be 200 times 0.9, which is 180, and the variable will be the previous variable value, which is 410, plus 10, 420. So click next, 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 next. As you can see here, Now the payload is 180 and the variable is 420. We have processed the second element. We have processed 2 elements so far because we say this is sequential. Click next again. Now what do we see? After we click this, what it prints is, oh, sorry, let me move this around. Now it printed the payload is 270 and the variable is 430. For the last iteration, our input payload is the last element, which is 400, but we said it accesses what has happened to the variable. In each iteration, it knows what happened to the variable in the previous iteration. So rather than adding 10 to the original variable value, which is 400, it is keeping adding 10 because the variable is being updated basically. So when I click next, our last value, our last iteration, as you can see, the payload is 760, which is 400 times 0.9, or 4 times 9 is 36, and the variable is 440. So this is how for each does a computation, or how it does its processing. So this is how we should understand the scope. Now the concept is, okay, we have done like this. Outside of for each, once I exit that, what is my payload? What does my payload look like? And do I have access to the variable that was created, to the variable that was created in the for each scope? In this case, the last variable inside the for each is the other thing. So I am here inside this logger has not been executed. Now if I click next, it comes to here and see what it prints at the end. It prints the original payload. See, the payload is 100, 200, 300, 400, which is the original payload. So even if we have been applying 10% discount in the for each to each one of them, at the end, when it exits for each, what we see is the original payload. What about the variable? The variable is not the original variable. What we see is the variable from the for each scope. So remember this. For each, once it exits, the payload is the input payload, but the variable, you have access to the variable from the for each scope. As the first thing, now in here at the end, by the way, in the transform message, I'm just adding this last payload so that it returns this message to postman. So it doesn't matter, it's not important part of this concept. So if I click finish, I come here, message flow completed successfully, the last payload basically from this transform message. So that is for each scope. Now if we get back to the slides, it will make more sense. Just focus on the for each column. We said it processes individual elements sequentially, one after the other. Yes, we saw that. It processes the first element 100 first, then 200, then 300, then 400. We saw how the payload was changing. The second row returns the original payload. Yes, even if it applied 10% discount to each one of them, after it exits for each, what we saw is the original payload. Modifications made to the payload in the scope are not reflected outside of the scope. Yep. And the last 2 bullet pointers, new variables or modifications to existing variables that take place when processing one element are visible during the processing of another element. Also, yes, that is why it was adding, that is why it became originally initially the variable value was maximum of the payload, which is 400, but since in each iteration it has access to what happened to the variable in the previous iteration, it was keeping adding 10, and that is how we got the last variable value of 440. And this bullet point, variables created in the scope are accessible outside of the scope. So that is what we saw. Now let us see, before we go to the next slide, let's see with parallel for each. Parallel for each, how does it behave? So clear console, I want to see what this print is. The path is P for each, just add P here, P for each. So as I said, this project is also in GitHub. You can just get it from there. Let me show you which one it is. Yeah, here. So for today's class, we have this for each parallel for each scope, understand the scopes of for each and the parallel for each. And under quiz also, we have hands-on quizzes for each and parallel for each. Okay. So the same thing, the only thing what changed here is the for each, we changed it with parallel for each. Now let's understand how the mid event structure changes. So click send, the request has been sent. Come here, as before, we have payload with 4 elements, which are shown here. The variable is the maximum of the payload, which is 400. Now click next processor. As you can see, you see here the same thing like before. Now this one will be, the execution is in parallel. So you will see it doesn't complete one iteration and come back to another iteration. Rather, it will stay the set payload. I will click next processor 4 times. So each one of them, see here. So click, okay. The payload is 100, you see. Next, it doesn't move with this one because it is in parallel. So it will show me each payload value. Now the payload is 200. Still, even if I click next, it is still in the set payload. Next. Now the payload is the last one. Next. Now it comes to the variable. The variable also, I will click for a couple of times, which is the first 4 times. I will click 3 times because one time it will be already there. So 1, okay. Okay, did it get to set payload? Okay, let me see. Okay, what do we have here? Oh, okay. Initially they were inputters. Now it is applying the 10% discount. That is what I see. The update is here. The payload now is 360. Click next, next, next. Then now it has applied to 4 of them the 10% discount, and the variable has also 10 has been added to the variable. However, in this case, the variable, so for the variable, it is not adding 10 in each cycle because it is in parallel. It will just add 10 only once. As you will see, now let me print the payload and the variable values. This one, okay. This one also, yeah, because the logger also, it printed it a couple of times. So come here. What do we see here? So the first thing we see is the payload is 180 and the variable is 410. So the payload is 180 and the variable is 410. So basically, the 200 has been completed first, is what this is telling us. This in the input payload we have 200. When you multiply it by 0.9, it becomes 180. So that's what we see here. The payload is 180 and the variable is 410. The original variable plus 410. So assume you are giving 4 people, you are giving them, each one of them, you are giving them a variable of 400 and they are telling them to give you back 10% discount of each number. So the person who took 200 has applied the 10% discount first and came back to you with a result. That is what we see here. When I click next, okay, the line break is there again. So you see now the person who took 400 has completed. So you see the payload is 360 and the variable is still 410 because each one of them, they don't have access to what the other person did. Just they have the original payload, the original variable. Each one of them, they took a variable of 400 and they are adding 10 and to the variable, updating the variable by adding 10. And the payload, they are applying a discount of a 10% discount, simply multiplying it by 0.9, as you can see it here. So that's what we see here. Since this is in parallel, you don't necessarily see the input sequence. It will not be in the input order. It can be in any order. If we rerun this again, we may see it in a different order also. Click next. Okay. Now the last one, the last two we see the person who took a payload of 10 has applied the 10% discount. You see the payload is 90 and the variable value is 410 is what we see here. And the last one, which is a payload of 300, you see now when 10% discount is applied to it, you see the payload value is 270 and the variable is 410. So you see for each one of them, the variable didn't change. Before it was adding, it was increasing, it was adding 10 to the previous variable value. But now in here, it is adding 10 to the original variable value, which is 400 in each cycle. That's what we see. And the other thing is also the order doesn't matter when we have parallel execution or when we have distributed computing. Okay, now as you can see, it has exited the parallel for each scope. What do we get in the parallel for each scope is the important point, the other important point that we are trying to understand. Does it give us the original payload, which is 100, 200, 300, 400, and the original variable, which is 400, or does it give us a variable of 410, which is an output from this parallel processing, and the payload from this? And from the slides, we said it gives a combined result from each processing. If we say what we said, if I get back to the slides, so let's focus now on the parallel for each column, which is on the right here. So it processes individual elements using multiple threads in parallel. Yes, it does not return the original payload. So now we don't expect the original payload, unlike for each. What does it return? Rather, it returns the output message from each iteration. So it returns the output message from each iteration. And the results are aggregated in the same order they were in before the split. Let's check this. And also about the variable, the last row on the right, new variables or modifications of already existing variables while processing one element are not visible to the other iterations that we have seen. It was the variable value the variable output in each iteration was just 410, the original variable plus 10, and variables created in the scope are not accessible outside of the scope. So now we don't expect to see the variable modified in the parallel for each scope, and also we don't expect to see the original payload. Rather, we are going to see the 10% discount applied now in the output. In the output payload, we will see the 10% discount applied, but we will not see the variable, the input variable modified. Is what this is telling us. So let me clear the console and show you. Now, if I click next processor button here, so this is something similar to scatter gather because it is parallel execution. So we see here, it gives us not only the payload, but other additional information also. So from this here, you see the payload is, it gives us an array, and the elements in that array will be corresponding to each element in the input payload. So the input payload, we have 100, 200, 300, 400, 10% applied to each one of them. You see 90, 180, 270, 360 is what we are seeing here. 10% applied, but we see also other things also. So similar to what we were getting with scatter gather. So if you want to get the payload only, then you can extract from this array elements. You can take just the payload only. What about the variable? What happened to the variable? And the variable is, see at the bottom here, the variable, even if what was being printed to the console when from the for each scope was 410, now it shows the variable is still 400. So this is the original variable. The variable, the original variable, the payload, modified payload from parallel for each. From for each, the payload, the original payload, the input payload, the variable, output variable from for each is what we have seen. Okay, and let's summarize this. Let's see the next slides, and then I will take some questions if you have. Before, I think since we just have only 1 hour, the project, it is a similar concept, a little bit. It has, since it has scatter gather in it, the output will be slightly different. Try to understand what is happening, but I think it is similar concept. So since we don't have much time, I will, after taking some questions, I will proceed to, I will cover Google Keep. So we covered this slide. Now let's cover this slide. Okay. The first row about when each one of them encounter an error. The first row, what does it say? For each stops processing and invokes an error handler if one element throws an exception. Because this is in sequence, if one execution, one iteration fails, then it will throw an error. It will throw an exception. Whereas for parallel for each, they are being analyzed in parallel. So it processes all elements, even when there are intermediate elements that throw exceptions. And it will tell us a summary of which ones failed. This one's failed, this one's passed, kind of summary error at the end. But it still processes all of them. Is the first row. What is the first row is telling us. And both for each and parallel for each support different content type, application, Java, JSON, and XML. The other important thing, I encountered this one. You may encounter also when doing the previous exercise, the previous assignment that I gave, ingesting data to the databases, small size, large, medium size, large size data, inserting it using for each, parallel for each, bulk insert. These are what we covered. So parallel for each, what it is doing is it creates an intermediate result from each iteration. So there is an intermediate result from each iteration before giving the output. So that means when you have large volume of data, it may run out of memory. So for each, it analyzes each iteration, each element, then it is done. Whereas for parallel for each, it is collecting it. It is collecting like the first, like I give some tasks to 10 people. The first one will bring, okay, I will save that. The fifth one also brought their result, okay, I will save that, and so on and so on. So there is an intermediate list. And what happens is if there is a large volume of data, it can run out of memory. And you may encounter this error. I encountered this once when I was importing, processing large volume of data using parallel for each. And as Anwar also showed us last time when using OneNote or Google Keep, I mean, you can keep track of such kind of errors that you encountered, and during interviews, you can use them to answer questions. Any kind of errors encountered when working on a project and how we solved it. So if you were using parallel for it, the data volume was large and the error was it ran out of memory. Then I solved it by using batch processing. This batch processing is what we are going to cover in tomorrow's class. It is very important concept. So don't miss tomorrow's class. So this is all about the scopes of for each and parallel for each. Now I will move to Google Keep, I guess. Let me move to Google Keep and then I will take questions at the end. So Anwar, last time he covered about OneNote, how to organize our notes using OneNote. For those of you who were not there, let me open it and show you. OneNote, MuleSoft, OneNote is here. So if I click, just let me open them. So we will compare OneNote and Google Keep. They are totally different. They are very different, I would say. Both of them, they help track some notes, but OneNote is more kind of, it looks like more traditional note keeping, whereas Google Keep is just some post-it notes. but you can organize it. Post Google Keep also, it has its own advantages. So each one of them have, I think, their own pros and cons. I will show you. So this is OneNote that Anwar showed us last time. It helps you to organize your notes, any kind of important articles you read online, and you can just copy paste important lines or important concepts from those articles and include URL of each article. It can also be any screenshots, images, and also voice memos, and so on. You can organize like this. He has created definitions, platform, design on different topics, basically on different topics, and each topic will have subtopics. So this is like folder and subfolder structure. And I found a similar one with Google Keep. The reason that I decided to move with Google Keep is because I use Google other Google products a lot at work, including at work. So in Google, from Google products here, if you go here, we have, I usually use the sheets, docs, and sliders, and there is also another one, Collab, and Google Drive also. And I found Google Keep easy to organize. So you can have, as you have lots of more and more things in Google Drive, it could be difficult to get it. But you can just add some notes to Google Keep. So that is one advantage. It can be from Google Sliders, it can be from Google Docs, it can be from Google Drive, and so on. So let me show you that. So if I come here, this is my Google Keep, by the way. So what do we see here? It is not structured in the folder subfolder structure like OneNote. I would love that, but they don't have that. Rather, what they have is they have, you can add labels like tags. So I created different labels here. What do we see? We have AWS, books, cloud, and so on and so on. So we have created different labels here. And as I said, since they don't have folder subfolder structure, I'm just for MuleSoft, for example, I'm creating structure similar to Anwar's. And what I did is MuleSoft 1 introduction, so that they are in the same order. But it looks ugly here as maybe the first time, but I will show you how convenient also it becomes on some things. And I have created all these labels. I think you can add up to 50 labels here. So when you add notice, let me go to here. When you add notice, the advantages, as I say, the first bullet point, it says easy to integrate with other Google products, including Google Drive, Collab, Docs, Slides, and so on. So let me show you here what I have with that. So I have, this one is, you can also pin. Let me unpin them. The ones that you want to see on the top, you can pin them. Oh, okay, I am under code. Let me go here so that I can show all of them first. I have two notes pinned on the top. You can pin the ones that you want to read. The ones that you have read already, you can move them to the bottom or unpin them where they were pinned. And for each note, you can add multiple labels. So see the first one, data structure tutorials with Python, some articles that I found online. You see the label is Python, which is this one. Whereas for this one, it was a video I watched yesterday from MuleSoft. They released it yesterday, and I found this image is important. This concept it is YouTube video, so I added screenshots of the screenshots of these images, as you can see, and the URL also here. So, and it covers different topics, including designing, development, platform, security. So it is basically the concept mainly it is about API governance, but it covers other things also. So I added those levels also. So when I want to read about any topic, I just can come here and see what notes I have under that topic. And one note can be can be under different categories. So I can get it in each level. Also, I can even search here. Searching is also easy. So if I search this MuleSoft, I will see notes that have MuleSoft in them. So I have the books, for example, that the Silent shared recently. They are in Google Drive. So if I don't know where they are in Google Drive, I can just organize them like this way and can come click here, then it will take me to Google Drive. So here it is in Google Drive. Also, let me show you, images also. You can add some images I have added, and that is Google Drive. Here we have Google Docs. This is a Google slide. I added these, the course slides. So Google slide here. So it is this one. And it is easy to add from any Google products to Colab. So for example, let me show you this one. If it is not added already, I can just add it. Let's see. I just click this one, SQL Crash Course. When I do like this, right click on it, save to keep. Here is save to keep. So I will see it added to keep. So SQL Crash Course is here. The title is that one. And since it has already been added, it has tagged it, but I can modify the tags under which category it will be. I can pin it and so on. Once I do that, I will see this added there in the Google Keep. Also, let me show you doing the same thing with Google Docs. For example, if I go to Google Docs and have this one, I was working with one document for tomorrow's class. It is this one with a batch processing. So let's say I want to add this to Keep. Just right click on it, save to Keep. So you can bring from Keep to Google Docs, to include into Google Docs and Google Slides, or you can send from here to Keep also. So save to Keep comes here. So the title is this one, and just done. Now if we go to Keep, we will see it here. If I go to Keep under Notes, you see here it has been added. Insert data into database using batch job. So I see it here. You can add as many notes as you want. And other important advantages about this is also, so I covered this one. Yeah, you don't need to install anything. It is just Google product. You can access it from your phone or from other computers. That's a very important thing, especially for me or for those of you who use Python also. You can include code. You can just run code in Google itself. So let me show you. For example, I have this one. You see here, it says Google Collaboratory or Google Colab. You can run Python code for free using Google's computers. So you see the tags here are code, Colab, Python. So if I just click this one, okay, let me see. Launch it by clicking this go to link. So it will take me to my notebook. So here I can run my code, basically. Just run my code. Here, connect to Google's computers and run my code step by step. I have this one, and especially when you are learning something and you want to put it so that other times you can use it as a reference, it is very nice to run it this way. You don't lose it. If it is in your computer may get lost and you may not know where exactly it is. But if it is in Colab, you can organize it this way. You can run code also, live code also. Just I can click this and run the code. Let me show you if I have another one. If I go here, so I'm looking for code or Colab, I can go either to code or Colab and it will take me to this. I can have other code also. So I have this one, multiple time series forecasting. So let me launch it and show you. I chose this because it has visuals. So you see step by step, there are code, some documentation, some results, and so on. So this is about forecasting something. And you see the forecast is how it is performing and so on. Also, I see that. So once I study this, I understand this new this new tool, practice like this, and put it there. When I need it, I can just come to Colab and easily get it. Okay. Another important thing is you can create a note using speech when you are using the phone, and that is the reason I joined using my phone. So I will share my screen from my phone. Let me first stop sharing here. So share. Okay, perfect. So you see, this is my phone. Now let me go to keep. Okay. So I can read also on the go. I have all my notes here. It synchronizes very fast. I can create from my phone or from my computer, and then I will get it in each device. The other advantage is I can create also a note using voice dictation or just speech to text conversion capability of the application. So by the way, you can Google Keep is used not only for keeping such kind of notes, but it can be also easy reminders, for example, shopping lists and so on and so on. So let me say I am going somewhere and on the go I want to create some note and create a reminder for it. So I simply click the plus sign. Okay, using voice. Voice is not a plus sign, it is this voice icon. Okay. Doctor's appointment tomorrow at 8 a.m. I see. Okay. I think so. What is happening is since I am already on Zoom, it is not working for that reason. However, you can use that icon and just talk, and then it will create a note for you, and you can create a reminder. So I will exit from here and create one and show you once I log out from Zoom in my phone. So first let me end sharing. Stop sharing. So I will share my screen from my computer and go to keep here and leave Zoom from my phone. Now in my phone I am creating a reminder using keep. We have a doctor's appointment at 8 a.m. tomorrow. Okay, doctor appointment. I am adding a reminder tomorrow morning. So you will see it come here. Should come here. Yep. Doctor's appointment. You see it here. So I created it from my phone, but I can see it in my desktop also. So doctor appointment. Have doctor's appointment at 8 a.m. tomorrow. And there is a reminder here. Can see the voice. Let me put the voice. Have a doctor's appointment at 8 a.m. tomorrow. And you have a doctor's appointment. Sorry. You can add other people also, collaborators. Just add here. You can just add, for example, I can add my wife. So she will get an invitation about this also. It will be there in her collab also. So this is like, it is very good for rather than keeping list of things you will do in your mind and making your mind busy, just throwing it to Google Keep with a reminder is very handy. Then it will remind you in your phone, also in your computer. And the other thing is, let me just delete this one. The other thing is also, you can, let's create, for example, shopping list. To keep a note, you just click here. So shopping list, let's say banana, what else? Apple, and app maybe, and bread. These are enough, let's say. Then you can, if you go here, you can make it as checkboxes and add a collaborator and checkbox what you have already bought, and your other collaborator will bring the rest of them, and so on. Or checkbox the tasks that you have done already, and focus on the tasks, focus on the tasks that you have not done. And here also you can change. There is a way to change background color as well. Let me see. Add background color. You have these colors, different colors for each note. So these are like temporary notes about just something that you will complete in a couple of days, and then just to remove it. Once it is done, you can either archive it or delete it. Okay, delete note. The other very important thing that I found very useful for productivity is adding notes from anywhere. Let's say, for example, I go to MuleSoft website or anywhere. I'm reading some article. Let's see, read something different. So here, what is MuleSoft? These people are talking. There is how to use Salesforce and MuleSoft together. I want this one. I just right click here. Then I have an extension. You can add the extension for Google Keep. So there is Google Keep Chrome extension. Just click this. Now it is saved. I can continue reading. Another time when I come, I will get it in Google Keep. If I come here, you see how to use Salesforce and MuleSoft together has been added here. Then I can come here, and when I get time, I can add labels. To modify the labels, click add labels, and the different labels I have on the right are here. So, okay, this topic is relevant about, let's say, MuleSoft deployment and subquery, let's say. So I see that the labels I added. Oh, where are they? How to use, move down. If I come here, yeah, it is this one. So I see labels, it has deployment and security have been already added. So as you can see, it has its own strengths and weaknesses. The fact that you cannot create folder in the subfolder is its weakness. However, you can organize it like this. But its main advantages are it is easy. You don't need to set up or install anything, and you can it works smoothly with other Google products, and you can add from the other products to collab. And also, when you are writing anything on the other Google products, such as Google Docs or Google Slides, also you can add from Keep you can add to Google Slides and Google Docs, and vice versa. And running the code, if you are learning some programming language, it can be SQL or Python or other things. You can use Colab for that, and your code when you want to use it or read it, you will easily get it. And also adding notes using the voice dictation is also very handy. So these are the advantages I found important. So you have seen Google Keep, you have seen also OneNote. You have to use, I think you can use either of them. They are fine. Generally, as far either one of them is fine, which one you like, but just organize your notes in some way. And when you read different articles, you add that. Let's say if I go to MuleSoft help, and I found some errors there, important error people talking about with its solution, MuleSoft help. Some concept people are talking, then I want to use that in my interview, then you can just add it from there. So let's say MuleSoft, okay, help, let's say, for example, for each, let's see any errors about for each people are reporting. Okay, let me see, for example, this article. I was reading this article. Okay, this article, I want to add it. Simply, I go here, just go here, and if you found some new information there and you don't want to lose it, just keep lose what we were reading. We try to, this happens to me usually many times. I try to find it again and again. Didn't I read the solution? For some Python problem, for example, if I got some help online, I understand it, I solve my problem. After a couple of days or weeks or months, I encounter the same error, try to solve it, but I have forgotten what I did. And then keep searching the website that helped me. And it takes time. That really decreases productivity. But if you use Keep, it saves lots of time. So these are what I have for today. I guess the project, this one, you can run it in debug mode yourself also and understand what is happening. It is very similar. The only difference is we have a scatter gather, and we said the output of a scatter gather, even if the input is a single payload, the output of a scatter gather will be an object which is mule event, and that object will have mule event from each route. We said we have reviewed this multiple times, so remember that your payload in here will have a size of 2 in the variable. Just check that, otherwise the concepts will be the same as what we did with the queues. So this is all what I have for today. Let me stop sharing my screen and unmute you and take any questions you have.